Okay. Angle subtended by a chord at a point. So first of all, what you need to understand is how and on what basis will a chord subtend an angle. Do you know what do you mean by subtending an angle? Subtending, that means making an angle. Subtended, that means angle made by the chord at any point. Right? Will chord make an angle? No. The end points of the chord will make an angle. The end points of the chord will make an angle. So suppose if I draw a circle, it doesn't look like one, right? Okay. And if I draw a chord here, A and B, having both the endpoints on the circle, what will be this one? Center O, right? Now the endpoints of the chord here will make an angle, will subtend an angle. First of all, let us say at the center. So what will this happen is this one. So this is the center and this is the angle made. Let us say for example theta. Do you know what theta is? Theta is the name that we give to an angle. You can also call it as, we know different angles, right? For example, 30 degree, 40 degrees, 50 degrees, 90 degrees and so on. For reference, we know that these are some of the angles. So this is known as this theta here, or you can also call it as angle AOB. Angle AOB, that is the angle subtended by chord where at the center of the circle. At the center of the circle, right? Suppose if I am having one more point here, C, then if I connect the endpoints to this point C, assume that these lines are straight. This will not be curved lines, it's straight line will be. Barabar? Like this. Then this angle ACB. What is angle ACB? Okay, this will be angle subtended by the chord at any point on the circle, right? Like this. So this is known as subtending an angle, the chord subtending an angle. This chord is subtending an angle at the center, namely angle AOB. Suppose if we have C point here, then that ACB will be the angle subtended by the chord at any point on the circle. Suppose if I draw another point here, or if I mark another point here D, then angle ADB, that will again be the angle subtended by the chord to any point on the circle. Now you can clearly see that this chord divides the circle into two segments, namely
Major segment
and minor segment. So this is the major segment, this is the minor segment. That will be the major arc, this will be the minor arc. Yes or no?
Yes.
You can also call that angle ACB is the angle subtended by the chord on the major arc.
Yes.
Similarly, if I draw or if I get a point D here, then this angle ADB, this will be the angle subtended by the chord on the minor arc.
Yes.
This is the minor arc, right? So this will be the angles subtended by the chord. Okay. How angles are being subtended by the chord? Okay. So these are the angles how these chord will subtend. Based on this, we are having some of the theorems. The proofs of these theorems are not important to us for the examination point of view, but yet we need to understand these theorems and we need to see that how these theorems will work for the future. The first one, it says that equal chords of a circle will subtend equal angles at the center. Equal chords will subtend equal angles at the center. Let us say, for example, if I am having a circle, I am going to draw two chords such that they are equal. Equal in the sense the length of those chords will be equal. Right? Equal chord એનો મતલબ શું? તો કે બંનેની length same હોય. Right? Suppose this is one and the other one is like this. Let us say we are having two chords like this here. Chord AB and chord CD. This is the center. I am marking it at some distance because I need to draw the lines here. Connect the chords. Chords means the endpoints of the chords to the center because we are subtending at the center of the circle. Right? So we will connect them here. Like this. Right? So there are two angles made at the center. Okay. Are those vertically opposite angles? No. Then how can we prove that these angles are equal? Can we? Yes, we can. Why not? If the theorem says, then there must be a proof for this theorem, right? Now we know that this and this are
Equal.
Will those be equal?
Yes.
Yes or no? How many of you say yes? The rest of the people will say no, I think. Sit straight. That goal. Yes. The rest of you will say no, I think. Yes or no? Aren't these all radii? OA, OB, OC, OD?
Yes.
Yes.
Are all of these radii?
Yes.
So, will they be equal?
Yes.
Sure?
Yes.
Okay. So, here we are having two triangles and as we proved in chapter number 7. Can we prove those two triangles to be congruent?
Yes.
We have different congruence rules, right? And we can prove them congruent by any of the rules that we can apply here. So we can say that in triangle AOB and triangle COD. What can you say about these two triangles? The first one, what is this? Equal chord. So the data will be given to us that AB equals to CD. Because chords are equal, the length of the chords are equal, so they will be equal. So first of all, in these two triangles, can I say that AB equals to CD?
Yes.
That is given.
Yes.
Then we can also say that OA equals to OC and OB equals to OD. They are radii. So, by which congruence rule can we prove that they are equal? Sorry, they are congruent? By which congruence rule can we prove? What is this? Side.
SSS.
So by SSS congruence rule, we can say that these two triangles are
Equal.
congruent, right? Therefore, triangle AOB is congruent to triangle COD by SSS congruence rule, and hence by CPCT we can say that angle AOB is equals to angle. So this is proved here.
Yes.
Then if the length of the chords are equal, then the angle subtended by them at the center will also be equal. Suppose if I add an extra chord here, that is, let us say EF, which is equal to AB and CD, then will it subtend equal angle at the center? Yes. Again, this angle will also be equal to the third one. Is that clear?
Yes.
So if the chords are equal in length, then the angle subtended by these equal chords at the center will be equal. Corner. I'm first. Then next is the converse of this theorem. Converse of this theorem, that means meaning same, but खाली हमें no exact negative meaning थी. The first one is equal chords of a circle will subtend equal angles at the center. Next is that if the angle subtended, right? Let me write it down here. Next theorem says that if the angle subtended by the chords at the center are equal, then the length of the chords are also equal. Suppose that if I say that this angle theta1 and theta2 are equal, then the length of the chords are also going to be equal. We can again prove it like this. Yes or no? We can again prove. If I take the same figure here, then we can again prove it like this. How? Now we are not going to take this A, B and C, D as equal, the first one. In place of that, we are going to take angle. In place of that, we are going to take angle AOB is equals to angle COD. Right? So in place of that, we are going to take angle AOB is equals to angle COD. Now just erase this one, the first line. This both will remain the same. Now which theorem can we apply here? Which rule can we apply here? Okay, this is the side. Sorry, yes, this is the side. This is the angle, and this is again, where is the third one? Okay, here it is. The side. You can clearly see that this side, this angle, and this side. So by S, AS, because this angle is now being included here in between. Yes or no?
Yes.
These two are the radii. Similarly, these two are also radii, and this is theta 2 somewhere here. So by side, angle, side, by SAS congruence rule, we can say that triangles AOB and COD are equal, and hence by CPCT we can say that these two chords will also be equal. That means AB and CD are also going to be equal, right? So we can prove it by that, but the proof again is not necessary. So we are not going to prove that. We are not going to write down that. Is the first and second theorem clear?
Yes.
Yes or no? Is the first and second theorem clear? Yes or no? Yes. Right? Moving on to the next topic.
Second also.
Okay. Again, let me explain you the second one because I'll need to rub the board there. If the angle subtended by the chords at the center, suppose you can see that circle and the two triangles inside. I'll take those two triangles outside like this. It will be clear if you understand it like this. What is this? O, A, B. This is O, C, D. Yes or no?
Yes.
Okay. Sure. Further, given. What is given? This. AOB and
COD.
they are.
Equal.
What is this? OA?
Radius.
Radius. Good. What is this? OC?
Radius.
OB?
Radius.
OD?
Radius.
Now you can just see the congruence. OA equals to OC, angle AOB equals to COD, and OB equals to
OD.
OD. Hence by side, angle, side. Because A, the angle, is included in between the sides. Is included in between the sides. So this will give us S congruence rule. And hence by that congruence rule, these both sides or these both triangles are congruent. If these both triangles are congruent, then by CPCT, we can say that AB is equals to CD. Meaning, we started from taking equal angles, we ended at proving that sides opposite to these angles are equal. It means that if the angles subtended by the chords at the center are equal, that means if AOB and COD are equal, then the length of the chords are also equal. That means AB is equals to CD. Clear with this?
Yes.